So how do we measure H plus and hydroxide in the lab? This is one of the easier things you can do in the lab, measure H plus and hydroxide. You can use what's called a pH meter. How a pH meter works, we'll just leave that to another course. But basically, with a pH meter, you can measure the concentration of H plus, or more accurately, the activity of H plus. But at this level, we're just going to say that's the concentration of H plus. pH is defined as the negative log of the concentration of H plus. So that means H plus would be, okay, so if pH is negative log of H plus, then negative pH would be log of H plus. If I take the antilog of both sides, antilog of negative pH is 10 to the negative pH, that would be your H plus. So if you measure the pH in the lab, take its negative, take its antilog, then you get the concentration of H plus. Once you know your H plus, then you can easily calculate your hydroxide. How? Well, H plus times hydroxide must be equal to Kw, and you know Kw is 1.00 times 10 to the negative 14. So to solve for H plus, divide both sides by, solve for hydroxide, divide both sides by H plus. Okay, and so you'll find that your hydroxide is just Kw over H plus concentration. One thing you'll also find is that, here's another way of looking at it. Since H plus times hydroxide is equal to Kw, okay, if you take the log of both sides and take the negative of the log, let's just take the log first. Log of a product is equal to the sum of the logs, right? Log of H plus times log of hydroxide would be log of H plus plus log of hydroxide is equal to log of Kw. Okay. If I were to take the negative of both sides, then this is the negative of log of H plus plus negative log of hydroxide equals negative log of Kw. What did we say is our notation for the negative log of something? It's P something, right? So this is just pKw, and we call this pOH, and negative log of H plus is pH. So pH and pOH add up to 14. Because what's Kw? Kw is 1.00 times 10 to the negative 14 at 25 degrees. So pKw would be the negative log of 1.00 times 10 to the negative 14. Okay, so what would that be? 3 significant digits. So that's 14 followed by 3 zeros. Okay, 3 decimals. So 14.000. So pH plus pOH equals pKw, which is 14.000. So if I know my pH, I can solve for pOH easily. All I do is subtract pH from 14. Okay? And then if I know pOH, then hydroxide will just be the antilog of negative pOH. So let's illustrate that with some calculations here. Let's say the pH of a solution is 4.00. Okay, what is my H plus? What's the definition of pH? Negative log of H plus. So how do I solve for H plus? pH, H plus is 10 to the negative pH. So 10 to the negative 4.00. What would that give me? That's just 1 times 10 to the negative 4, right? Okay. Yeah. Negative 4. Okay. 10 to the negative 4. 1 times 10 to the negative 4. But how many seg figs should I have? 2 decimals in the pH means I need to have 2 sig figs in my answer. So it's 1.0 times 10 to the negative 4. Okay? What is my pOH? pH and pOH add up to 14. So it's 14.000 minus pH. So 14.000 minus 4.00, that gives me how much? 10.00. Sig figs. Okay. How do I get hydroxide? It's 10 to the negative pOH. So that's 10 to the negative 10.00. So that's going to give me 1 times 10 to the negative 10. 2 decimal places, so I need 2 sig figs here. 1.0 times 10 to the negative 10. So that's my hydroxide. Okay? Now, what's another way I could have figured out my hydroxide? I could have said hydroxide equals Kw over H plus, right? So it's 1.00 times 10 to the negative 14 over 1.0 times 10 to the negative 4. That's my H plus. Same answer. I get 1.0 times 10 to the negative 10. Okay, so by measuring pH, you should be able to figure out H plus and hydroxide concentrations. And if you're doing that in the lab and the pH is not changing, then that means you are at equilibrium. You have the equilibrium values for H plus and hydroxide. Okay, so the pH scale then tells us whether your solution is acidic, basic, or neutral. What did we say? H plus and hydroxide is in a neutral solution. They're equal, right? So if they're equal, they both have to be 10 to the negative 7. So your pH and pOH must both be 7 if you have a neutral solution. How do you get an acidic solution? If your pH is higher than 10 to the negative 7, what's a number that's higher than 10 to the negative 7? Example. 10 to the negative 8? That's lower, right? So 10 to the negative 5. So 10 to the negative 5 is an example of a number higher than 10 to the negative 7. What's a pH if it's 10 to the negative 5? If H plus is 10 to the negative 5, then pH is negative log of that. It's just fine. So if pH less than 7, your solution is acidic. pH greater than 7, you say your solution is basic. You have more hydroxide, less H plus. Okay? So pH is lower in acidic solution. Okay? And same thing with pOH. If pH is less than 7, then your pOH must be greater than 7. Right? So if my pH is 5, what's my pOH? pH and pOH should add up to 14. So 5 plus 9 is 14. So pOH would be 9. Okay. So, clicker question. pH of a solution is 4. Which of the following is true? A, the solution is basic. B, H plus is greater than hydroxide. Very good. pH 4, less than 7, acidic. So A is obviously wrong. And if it's acidic, then you have more H plus, right?